On the track right, which numbers we want to see, go over, have questions about? A lot of 4s and 5s. 3 can be done on Desmos, so we'll do that. I saw a 1 and a 2, so we'll end up doing all of them. 1 and 2 cannot be done on Desmos, so we'll talk about those first. So for number 1, when you're translating 6 less than, that's going to go at the back. 4 times a number, pick whatever variable you want. Because it says squared at the end, everything is going to be squared. So if it said 6 less than 4 times a number squared without the comma, then just the x would be squared. But because it said it at the end, everything would be squared. Questions on that one? Combining our like terms. Be careful with your negatives. I don't know why I did that 3 times. So we have 12x plus 8 plus 10 minus 2x. And then combine your x's together and your constants together. 10x plus 18 should have been that answer. The only way you would be able to check this in Desmos is if you put this in with like maybe a capital X and added a, what's it called, slider, and changed the slider to see if the numbers were the same from the original index. And if they were the same, that would tell you the answer, but it doesn't really show you how to get there. 3 you could do by hand or in Desmos calculator, whatever. So if you put in, you can just put it in with parentheses. I forgot what it said. Can I borrow your calculator? Yeah. Negative 3, thank you. So if I just put in the second part, wow. Okay. Try that again. Negative 3. I'm drawing that blank. Okay, there we go. Squared plus 2 times negative 3. You should get 3. So then you would write your final answer as f of negative 3 equals 3. Or f of x equals 3. And I meant to ask this before we started, but remember that if you're given the number inside the parentheses, that's your x. If it says equals negative 3, that's your y. Questions on that one? Four can be done algebraically, but you can also do it in Desmos to visualize it a little better. So if I put in these two order pairs, negative 3, 4, and 4, 4, I can see that they're going to fall on the same horizontal line. So what would the slope of that horizontal line be? So if you did that algebraically and got 0, good job. To check that even further, you could have found the equation of this line, y equals 4, put it through there, and then thought about what is your slope of a y equals. So that's even more visualization. Right, but your answer was m equals 0. The last one, so you could have done this algebraically by doing y minus y1 equals m times x minus x1. You could have started at this point, negative 2, 4, and then use that with your slope, and then it would have graphed the line for you. If you were using Desmos, you could have done this. If you typed in your slope-intercept formula, y equals mx plus b, it'll ask you to add sliders, so you can add all of them. We know what the slope is. What was it? Negative 2/3 or positive 2/3? Negative 2/3. And we know it has to go through the point. What was that point?
X positive 4, 1.
Okay. So because it has to go through that point, you can adjust your y-intercept until it does. It happens to be a decimal when you do that. It doesn't want to stay at the decimal it's supposed to be at. It's supposed to be 2.7. But if you started at this point and then use your slope to go down to right 3, that would also work. So either or. Just make sure you have that line graphed. What questions do we have on this so far? So today we're going to talk about the last way to solve systems. We talked about graphing and substitution. Now we're going to talk about elimination, a different algebraic method. So on these notes, I'm going to have you write these down. Write this down. As you're writing, I'm just going to read through that. So the elimination method is where we add / subtract or multiply and then add / subtract to eliminate a variable. Make sure the equations are lined up first. Add or subtract the equations to eliminate the variable with common coefficients. Solve the equation, for the remaining variable. And then substitute your answer into either equation and solve for the other variable. So as you're writing, you may recognize that step 3 and step 4 are really the same as substitution, which they are. Step 1 and step 2 are different. And then we'll talk about what happens when they're not common coefficients and how we have to multiply one or both. So we will start one problem before lunch, but we may or may not finish it. We'll see. So we're going to start with number 1. You may need more space, so if you want to write on the back of that first page or like tear it off so you can write and not flip back and forth, or grab extra paper, you can do that. So first, we have to make sure these line up, so the y's are on top of each other, the equals are on top of each other, the x's, and then the constants. That is the case here, even though this x is a little off. then we're looking for which of the two variables have the same coefficient. One. So they both have a 1. Whichever one has the same coefficient, that's what we're going to eliminate. What does eliminate mean? Get rid of. So we're going to get rid of the y's. We have to think about how we would do that. Would we add these together or subtract them to eliminate them? Would y plus y give me 0? Really? So then we're going to subtract the entire equation from each other. So 1y minus 1y would give us 0. 3x minus x would give us how many x's? 2x. And then 4 minus a negative 2 would give us what? Whichever with your negatives. So then once you have eliminated one, you're going to solve for the other variable. Get that one by itself. Subtract 6 and divide both sides by 2. We will find y when we get back from lunch. So we found x. Now we have to go back and find y. So you can put this in either of these two equations. Does not matter which one. I'm going to put it in the second one. So what would your y value be? Be careful with that. Double check that. -5. So then our ordered pair would be -3, -5. Before we move on to another, what questions do we have so far? So let's do number 2. The format is different, but it doesn't matter as long as everything still lines up. So we have x, y equals constant. So they all line up, so that's fine. Which variable has the same coefficient? X. They, again, both have a 1. So we would add or subtract those two to eliminate them. And for this, if you guys want to say answers out loud, you can. So let's subtract. This would give us 0. 4y minus negative y would give us how many y's? 5. And then 13 minus 3 is 10. So then we would divide both sides by 5. I'm ignoring the 0 because that wouldn't change anything. So then our y value is 2. Now we have to go back and find x. You again can put it into either equation, whichever one you want. I'm going to use the second. So x minus 2 equals 3. And solve for x. So then our ordered pair would be 5, 2. What questions have now. Let's move on to the next one. Matthew, something like that. Let's skip 3 and go to 4. 3 would be the same thing. You can find your common coefficient and then eliminate. 4, the x's have the same number, but one of them is negative. That doesn't matter. So we can still choose x to eliminate. And then would we add these together or subtract? Add. And if you're not sure, you can double check it in your calculator. So we did this earlier. If I do 4 plus a negative 4, I should get 0. If you don't get 0, double check your signs, but then also change it to the other one. So if we add everything, the 4x and the negative 4x just become 0. 9y plus 7y gives us what? 16y. And then 5 plus 11 is also 16. So then we can divide both sides by 16. So that y is 1. Please make sure you're writing this down. Please now make sure you're writing this down. So then take that y value, put it into whichever one you want. Let's say I put it in the first one. So 4x plus 9 times 1 equals 5. Then you would solve that for x. So get rid of the 9. And divide everything by 4. So then what would be our ordered pair? Do we have any questions so far? Let's do 5. Are the equations for 5 lined up? The equals aren't in the same place. So then you have a choice. You can either rearrange the top so that it matches the bottom, or rearrange the bottom so it matches the top. Which would we prefer? Bottom to match the top, or top to match the bottom? Okay. So if you want the top to match the bottom, the 3y needs to be on the other side. So we would subtract it. So I'm going to rewrite that underneath. Now they are lined up. Which variable are we going to eliminate because they have common coefficients? Y. Would we add or subtract these? Are you sure? Mm-hmm. And for these, if you're not sure, you can still double check. So -4 minus a -4 should give you 0. In general, if you have 2 positives or 2 negatives, you should be subtracting. If one of them is positive and the other is negative, you should be adding. So then 2x minus -x would give us how many x's? minus 11 will give us negative 1. So when we solve this, we're going to end up with a fraction. That's okay. It happens sometimes. So then we're going to put that back into, you have 3 choices now. You can do one of the originals or the one you changed. Does not matter. I'm going to do this work up top. And I'm going to use the 2x equation. So then we would be using that to find y, multiply add 2/3 to the other side. When you do that, what do you get? It's some weird fraction. 32/3. And then to get y by itself, normally we would divide, but that would be dividing by a fraction. So instead, we're going to take the reciprocal and multiply it on both sides. So that y is, oh, it was negative. Negative 32 ninths. So then our ordered pair would be negative 1/3, negative 32 ninths. It's a weird solution. Nature. It was the 3y was negative, but I didn't bring that down the second. So when you flip it, you're not making the negative reciprocal, it's just the reciprocal. Okay. Other questions on that one? Okay. Let's do 7. Which variable has a common coefficient? Yeah, they both do. So that should tell you that you're going to get a special case solution, either no solution or infinitely many, depending on the answer you get. So it doesn't matter which one you want to do. So let's say we get rid of x, or it doesn't matter. How would we eliminate these? Subtraction. So when we do that, 3x minus 3x gives us 0. The negative 4y minus a negative 4y is also 0. Negative 10 minus negative 13 would be what? What would that be if we have negative 10 minus negative 13? So what type of solution would this be? No zero. not infinitely many? Because they're not the same nature? No, they're not the same. So if you get infinitely many or no solution, your variables will both cancel out, and that's how you'll know it'll be one of those cases. You'll either see that they both have the same coefficient, or when you go to subtract them, they both cancel out. So keep that in mind. Okay, we'll just do a few more, and then any you guys want to see, and then we'll be done for today. So let's go to 9. Yes.
Question.
Mm-hmm.
Does it matter that it didn't have an equals on it?
Oh, it was supposed to. This was supposed to be the equals. I think that was a typo. But yes, that definitely matters to nature. So that one more time. And you get 0 equals 0, yes. Okay. For 9, do we have common coefficients? No. So then in this case, you have to make common coefficients. So you can choose whether you want to eliminate x or y, it does not matter, so you have choices. I'm going to eliminate x in this because it'll be a little simpler. In order to make them the same, we're going to have to multiply one or both of them by something that would make them the same. So this one is already 2. So if I were to multiply this one by 2, I would get the same thing. Or if you wanted to multiply by -2, you could also do that. It depends on, would you rather subtract the 2 together or add the 2 together? So I'm going to rewrite that below it. 2x plus 6y equals 12. Now they have the same common coefficient. Now we can solve it. So would we add or subtract these? Subtract. So I'm not going to put the 0, but you can still keep putting the 0. -7 minus 6 will give us a -13y. And -1 minus 12 would also be -13. Divide both sides by -13 so that y is 1. And then put that y value into one of the equations. Solve for x. I'm going to put it into the first one. So we have x plus 3 times 1 equals 6. X plus 3 equals 6. Get rid of the 3 by subtracting. 3, 1, bless you, would be our final answer. What questions do we have on that? Make a pass. Let's try another. 10. Do we have common coefficients? No. So we need to make one of them common. Does not matter. Do we want to eliminate x or y? Okay. So if you want to do y, you're more than welcome to do that. We need to think of something that these both go into that we can multiply them to get to that number. So think of some number that these are both factors of. 15. So we'd have to multiply the first one by 5 and the second one by 3. So you're going to end up changing them both. So to go through. I'm going to rewrite both of those underneath. 15x plus 15y equals 45, and 15x plus 12y equals 30. Now we have the same common coefficient. Would we add or subtract those together? Subtract. 15 minus 12y would give us 3y. 45 minus 30 would give us 15. Divide both sides so that we get 5. And then once you have your y, put that back into, now you have 4 choices. One of the originals, or one of the 2 you just changed. Any of those 4 work. So let's say I'm putting it back into the very first one. 3x plus 3 times 5 equals 9. 3x plus 15 equals 9. Get rid of 15. And divide by 3. So we have negative 2, 5. What questions do we have there? And let's do one more. 13. We don't have common coefficients. We need to make some. Do we want to eliminate x or y? Nature. Okay. And if you want to eliminate y, go for it. So we'd have to make these both the same. You can do that by many things. Just changing the first by multiplying it by 5 or negative 5. Changing both of them by multiplying the first one by some multiple of 5. 10, 15, keep going. And the second one, how you do that is up to you. So there are so many different ways to do this. But I'm just going to multiply by 5. That would probably be the easiest. The higher up you go multiplying, the bigger your numbers get. We have 5x plus 5y equals negative 15. Would we add or subtract these together? This would become 0. Negative 2y minus 5y gives us negative 7y. And negative 50 minus a negative 15 gives us what?
Negative 65.
Be careful with your negative, but check it.
65.
So then if we divide both, we get positive 5. Put that back into one of your equations and find x. I'm going to put it back into our first one. X plus 5 equals negative 3. And get rid of the 5. So negative 8, 5 would be our solution. Of the ones remaining, which ones do we want to see, go over, have questions about? none, then there are 3 things you could be working on for the remainder of class. More practice in these notes, Khan Academy on this / pass, so ones that are due Friday or pass, or the SOL A3 that's due on Friday. So be working on one or any of those things. You guys can work together. Let me know.